In the 1950s, the United States wanted to design and build a terrifyingly powerful supersonic low-altitude missile, SLAM. It would be equipped with a nuclear warhead for devastating impact, as well as a nuclear-powered engine to provide unlimited operational range. Even by today's standards, this plan is still considered crazy. The missile is a retaliatory weapon, which can be used by the United States for timely and effective counterattacks after being struck. This approach was in line with the bipolar confrontation of the time. In order to increase range and speed, a nuclear-powered engine was chosen, and the use of multiple warhead technology was also considered to increase striking power. Different from our usual understanding of nuclear power, the missile, due to size limitations, could not directly adopt the nuclear power carrier's method of operating by boiling water for launch. For this reason, the United States initiated the Pluto program, with the goal of developing a nuclear-powered ramjet engine. The ramjet engine directly utilizes the force of high-speed flight of the vehicle, compressing a large amount of air through the engine intake by its own speed, without the need for devices such as turbines. The compressed air is then mixed with fuel and ignited to produce thrust, but how does this principle relate to nuclear power? The Pluto program eliminated conventional fuel and instead installed a small nuclear reactor in the engine, using stable nuclear reactions to generate immense heat. This heat is then used to further heat the compressed air, which is then rapidly expelled from the tail nozzle to generate thrust. Because the nuclear reaction can be sustained for a long enough time, theoretically, this type of engine could support the aircraft to fly anywhere in the world. Setting the engine issue aside for now, the missile itself, in addition to the warhead, also faced another important technological challenge: guidance. At that time, the United States had made great progress in miniaturizing nuclear warheads, but satellite systems did not yet exist. The missile initially flew by radio command during launch, and later used terrain matching to strike pre-programmed targets. This method was very advanced for the time and was essentially a type of cruise missile. The missile was designed as a slender structure with fins, and the engine intake was located on the underside of the missile. Due to its appearance, it gained the nickname Flying Crowbar. According to estimates, the missile could reach a maximum speed of 4.2 Mach at an altitude of 30,000 feet. The missile used a booster rocket at takeoff, and the ramjet engine began operation after reaching a certain speed. The supersonic low-altitude missile plan was abandoned in 1964 for many reasons. First of all, the engine technology did not meet the standards. The Pluto plan seemed feasible, but the technological conditions at the time were not sufficient to manufacture a miniaturized nuclear reactor that could be installed on the missile. According to calculations, the outer diameter of the reactor was 1.454 meters, the length was 1.632 meters, the core diameter was 1.2 meters, and the total power was 600 megawatts. Maintaining normal operation on such a small device required materials that could withstand high temperatures, good thermal conductivity, resistance to radiation, and also be lightweight, which would still be a huge challenge today. At the time, the United States did manufacture a test reactor and simulated the operation of the ramjet engine. During a short test, the air was heated to 506 degrees Celsius. I personally believe that it is feasible to generate thrust by heating the air through this method, but the technology at the time was far from practical standards. Another issue with the nuclear reactor was nuclear radiation, but the Americans believed that the impact of the reactor's natural radiation during high-speed flight could be ignored, as long as the missile itself had the ability to resist radiation. Another important factor that affected the missile plan was the intercontinental missile program. Compared to cruise missiles, intercontinental missiles achieved global strike capability through a different flight path, while also being quite fast, and almost impossible to intercept. In this situation, there was naturally no room for the development of the Supersonic Low-Altitude Missile Plan, SLAM.